Ladies and gentlemen, please welcome University of Wisconsin law professor and ethicist, Alta Charo.
Thank you very much. It's a real honor to be asked to speak here. And as somebody who does ethics, I think I'm going to be changing the tone just a little bit. Science is on the verge of an era of tremendous creativity, which is really revolutionary in its capacities. And from my perspective, it's going to ask us to debate whether and how we actually regulate, or even more profoundly, prohibit areas of research because they are disruptive to our own views. Now, in an extremely kind of overly generalistic and simplistic fashion, one might think about the 19th century as the century of invention, where we celebrated the mechanical advances, such as the battery and the locomotive. Some of them really were very disruptive. The light bulb changed the very circadian rhythm of our workdays and our recreation. And the telephone was also disruptive with mixed kinds of reactions. Those of you who are Downton Abbey fans may remember that the Dowager Countess asked if the telephone was an instrument of torture or communication. And I still actually ask that myself with my cell phone. But by and large, despite the disruptive capacities, invention was celebrated in the 19th century. We had the era of Jules Verne-type science fiction, and actually law went along with this by assisting innovation through various doctrines like assumption of risk, which protected innovators from liability even when their experiments went awry. The 20th century began to change in a little bit in our shift in attitudes. The 20th century was rather sobering because we really saw some of the destructive capacity of science. World War I introduces mustard gas and torpedoes. By World War II, as we all know, the atom bomb really demonstrates the power of science to destroy things. It led the bulletin of the atomic scientists to create a doomsday clock, which they set at 7 minutes to midnight, and about which they said, "Science has reached to the fringe of the universe and stolen the secret of life inviolate since the beginning of time." So it's no wonder that looking at that image of the atomic bomb, that we had Robert Oppenheimer saying quite famously, "Now I am become death, the destroyer of worlds." The atomic bomb and the H-bomb, these also led to tremendous fears about radiation injury, which is ironic in certain ways, because that was also the beginning of modern genetics. With the ability to look at the effects of radiation on genes and mutation rates, we see the very same technology associated with death, also associated with beginning to understand the secrets of life. That said, the 1970s still continued in a kind of science can be dangerous to our environment mode. We have the really dramatic images of the Cuyahoga River in Ohio catching fire, starting from the 1960s with Silent Spring and continuing into the 70s, the tremendous focus on environmental destruction due to the overuse of various kinds of pesticides. The result being that we have a kind of secular resistance to science beginning to develop in the 20th century, where things that are natural are considered to be better, safer, somehow more preferable, and things that are synthetic and plastic are implicitly considered to be somewhat dangerous and scary. Now, it's against this background that in the early 1970s, Paul Berg from Stanford was the first scientist to begin what we now call recombinant DNA research, in which he looked to combine monkey virus and bacteriophage in a kind of combination that had never been seen before in nature, and frankly probably wouldn't ever be created through natural processes of mutation and evolution. Now, he wanted to put it into an E. coli, but he realized that this actually posed some very significant threats to the environment if that got out and was uncontrolled and entered the ecosystem. It led to what is now very well known, the Asilomar conference taking place in California, where scientists gathered to discuss what the principles should be for this really disruptive, creative kind of science, where we look not at the power of science to destroy, but the power to create new kinds of organisms. The principles that they came up with were largely consequentialist. That is, what kind of harm can we do to humans, to animals, or to the natural environment? Let's take precautions against them. Some of you here may actually have worked in laboratories that had those extraordinary precautions that we took until we began to understand the level of threat that recombinant DNA really actually posed, which was considerably less. Asilomar, however, also had, just as a kind of throwaway, without a lot of discussion, a comment about how, of course, we would never use recombinant DNA to change the human germline, to change eggs and sperm and embryos in a way that would have transgenerational effects that would reverberate through our evolutionary future. They didn't say this because of consequentialist reasons, but they also didn't clarify whether they were doing it because they thought this was some kind of moral boundary or theological boundary or other kind of inchoate boundary that humans shouldn't trespass. They just threw it out there, and it's become kind of accepted wisdom until today, which is where I'll go by the end. Now, staying in the 1970s, I'll eventually get to modern times, we really did begin to see something more related to germline because the 1970s led into the 1980s with a variety of innovations in reproductive technologies. 1978 is Louise Brown, the first so-called test tube baby conceived through in vitro fertilization. Now, yes, there were consequentialist concerns about whether or not IVF would induce various problems, and in the 1980s, the conferences almost always began with large presentations on the rate of birth defects in children born who'd been conceived through IVF as compared to those who'd been conceived naturally, and so we did worry about consequences. But the deeper critique that began to develop in the 1980s and continued into the 90s about IVF and about pre-implantation genetic diagnosis and other kinds of reproductive technologies was a critique that focused on the idea that these were unnatural, that these were a violation of a kind of moral contract we have with our children to accept them without question, as opposed to choosing them based on characteristics, and that furthermore, for some people, this was truly transgressing a boundary that led us into a realm that is associated with a deity, and that therefore we should not be creating life. It's something humans should not have the power to do. That critique really did take hold, but IVF persisted. But then, by the end of the 1990s, we have the Roslin Institute in Scotland announcing that they have now successfully used somatic cell nuclear transfer to clone Dolly the sheep, right? Now, that was the first moment that we really begin to see this kind of general concern about the transgression of boundaries now become part of our public policy discussion and our legal discussion. Because this idea so disturbed many people that Congress immediately began to debate bills about banning this kind of research, and in a number of states around the US, they actually did pass laws to ban cloning. Now, it wasn't just to ban cloning that resulted in a live birth. It was also to ban the very research that might take place in a laboratory with no reproductive intent at all. This was the first time that we saw this kind of legislative initiative to ban an area of research without being able to point to some concrete consequence, like physical safety of the environment or health problems for humans, as some kind of justification, but simply a ban based upon a kind of what Leon Kass, a philosopher at Chicago, would call a wisdom of repugnance. Now, as both an ethicist and as a lawyer, I find myself asking, can the wisdom of repugnance be sufficient to justify legal prohibitions on an area of inquiry? Of course, again, with my lawyer hat on, I think about the First Amendment, which we all know protects all kinds of ideas and the expression of all kinds of ideas, no matter how difficult they may be. Indeed, the Supreme Court has given us very, very clear language that the government may not prohibit the expression of an idea simply because the society finds the idea offensive or disagreeable. This was really a radical concept at the beginning of our country because for generations, we've all had experience with fear of research leading to calls for some kind of prohibition. Go back 500 years, actually it's about 501 years from today, and it's Copernicus with his very disruptive theory that we revolve around the sun rather than the sun revolving around us, which Goethe said was a rejection of the kind of religious and cultural views about the singularity of humans. But it's not just 500 years ago, and it's not just religion, because more recently in the 1970s, when E.O. Wilson from Harvard began to extrapolate from his data studying ants to the possible data, to the possible applications to humans, he really founded a field called sociobiology, looking at how genetics might actually strongly determine the difference in behaviors and capacities as between men and women, or even as between groups from different geographic, ethnic, or racial categories. This was also an area of research that was decried, this time from the progressive left that was all bound up in the 1960s civil rights era of egalitarianism and a notion that nurture was far more important than nature, which led to very significant policy interventions about trying to give everybody various kinds of educational and other opportunities to level the playing field. And I remember in the 1970s calls to somehow shut down sociobiology research as somehow being so offensive or so wrong-headed that it shouldn't be done. So this instinct to look at research that disturbs deeply valued cultural, religious, or political beliefs is one that transcends generations and transcends politics. Now, when you look at something like this, I think we all understand immediately that the words are clearly protected by the First Amendment's protection of ideas. But what's more interesting is that the actual holding of the signs is also protected, because the First Amendment doesn't just protect speech, it protects expressive conduct. That's why the Liberty Tree in our early days, which hung effigies to protest taxes, was protected by the First Amendment. It's why draft card burning to indicate opposition to the Vietnam War was a protected expression of a political view, even though it did not involve any words at all. And it's why, ironically, flag burning, one of the most emotionally fraught areas in this kind of debate, flag burning is also protected as expressive conduct, even despite the irony that you're burning the flag of the country that actually gives you the right to burn the flag, right? So we understand that conduct can be protected as an expression of religious or political views, just like words. So here's my question in light of all these new reproductive technologies. If a scientist is doing this, is the scientist conveying a message about this? When I fertilize an egg in a laboratory, am I perhaps conveying a message about my views about the origins of life, the source of life, the need or lack of need of a deity? In other words, am I expressing something that is in a way fundamentally political? Now, Craig Venter is one of the more interesting biologists of our time. He's certainly a sort of more out there biologist, and he's done some unbelievably interesting work. Now, Venter has created something that comes about as close as we have come now to truly synthetic, off-the-shelf life when he created a self-replicating synthetic bacterial cell. This is how it was described in The Guardian, one of the UK newspapers. Quote, "Another triumph of the only scientific program driven from the beginning by explicit atheism." And indeed, when Venter was teasingly asked about this and about the kind of intelligent work that went into creating this cell, he admitted, facetiously perhaps, that yes, he had proved that intelligent design is real, right? Now, Venter's not alone in using his science to convey a point of view, right? Francis Crick, who was the developer of molecular, kind of invented molecular biology, once refused to affiliate himself with a new college at Cambridge if it were to have a chapel, because he too said that his work on molecular biology was done partly to prove that there's nothing mystical about life, that it's just the behavior of complex chemicals acting in accordance with the laws of nature, right? So for these scientists, the actual doing of the research is an expression of a point of view, which arguably would make it expressive conduct just like burning the draft card or hanging the effigy from the Liberty Tree. I think this is going to become a topic of more importance as we move into the next era these days of genetic engineering, which is the era of so-called CRISPR-Cas9. It's a kind of gene editing technique that's been developed out of MIT and Berkeley, which will vastly increase the ease with which we can do genetic engineering. It will allow people with far fewer skills and laboratories with much less sophisticated kinds of equipment to also engage in gene editing. And what's really interesting is that this now has introduced, once again, the question of whether or not, when we edit genes, there are any limits on what we should be allowed to change. Remember, recombinant DNA, all the way back in the 70s, already got us used to the idea of creating organisms that didn't exist ordinarily in nature. But now we've got the power to create perhaps a much wider range of things or a much more inventive range of applications. For example, already there's work going on so-called de-extinction to, for example, bring back the woolly mammoth. Other people out of Denmark, I believe it was, had suggested that perhaps we could use gene editing to bring back the flavor of heirloom tomatoes while maintaining the kind of long-term transport advantages that have come along with the hybridization that left us with the flavorless tomatoes we've all now come to know and love, right? Irony being, we'd use a modern technology of gene editing and genetic engineering to bring back something that the non-GMO people would like to have all the time, which is the old-fashioned heirloom varieties. Okay, we can understand perhaps these kinds of applications, although clearly there's going to be ecological consequences that must be handled, particularly when we're talking about de-extinctions, right? But then we have other things. There's an artist in Belgium that worked with a genetics lab to create a glow-in-the-dark rabbit. It's a bit of an exaggeration, actually, because of the fur. Mostly it was just the nose, the inner ears, and the paws that were glowing, but this is the artistic recreation. Why did he do it? Because he could, and because he thought it was an artistic expression. And next to that, a little harder for you to make out, and I apologize for that, a while back there was the invention of so-called GlowFish. This was done for purely aesthetic reasons for your aquarium. Fish that could glow red, yellow, green. But if you go on YouTube, you will find people who are taking those fish and turning them into GlowFish Sushi, which, by the way, they call traffic light sushi because of the red, green, and yellow lights, right? These are facetious uses. Again, if they don't hurt anybody, if the rabbit is not hurt by the bioluminescence, because we use that kind of fluorescing gene all the time, if the sushi is actually perfectly safe and it's not even being sold, it's just a personal kind of whim in your own kitchen, should that be banned because we think of it as a facetious use? Does it offend us enough that you'd use these powerful technologies for whimsy and art that we can forbid them? Now, more fundamentally, the question's going to be, what do we do next? We already are focused on disease prevention, a goal that everybody can applaud. This is the Oxitec mosquito with an older fashion of genetic engineering being used to try and combat the spread of dengue fever. But we look here and we see MIT Technology Review, along with every other magazine I can think of, immediately moving from disease prevention to enhancement. With gene editing, we have the possibility of editing the germline not just to, for example, delete the mutations that cause Tay-Sachs, which is an unremittingly miserable and pointless disease that kills children young, but is, in theory, capable of doing those things that we have been fantasizing about long before Gattaca and the other sci-fi movies. Can we increase height? Can we increase good looks? Or that holy grail of all designer babies, can we increase intelligence? So the question I want to leave us with really is, if, let's just assume, magically, we could actually be sure that germline engineering or these other synthetic life creations could be done in a way that really was perfectly safe for human health, for animal welfare, and for our environment. Is there a basis for prohibition based on morality or politics or culture? Or does the fact that some of these experiments, not all experiments, but a few experiments, are being done precisely to challenge those views, the very reason why we are not allowed to prohibit them. Last spring, some of the veterans of Asilomar, as well as the inventors of CRISPR-Cas9 and a few of the lucky hangers-on like me, got together to talk about how we should think about proceeding in this very fraught area. And we published a piece in Nature calling for a moratorium while people got a chance to think about whether or not this is an area, particularly human germline engineering, that we should not pursue. We wanted to ask if it's a boundary that we shouldn't cross because it's the purview of nature or of a deity or of some other kind of transcendent force. But I worry, because we called for a pause, not a prohibition, to think about this. I worry that there are people who are going to want to call for an absolute prohibition without thinking through some of the consequences. For example, when Richard Feynman died, on his blackboard was left the comment, "What I cannot create, I do not understand." If we do not pursue these areas of research, we lose not only the ability to challenge what we have been trying to, not only challenge our beliefs, but we also lose the ability to learn through the process of creation. Life sciences is on the verge of creating synthetic life. And robotics and artificial intelligence, I just heard, is on the verge of creating sentience. And the NASA chief scientist was quoted as saying, "We're going to find the building blocks of life within 20 years on other planets." Now, the only way we're going to know if they really are the building blocks of life is going to be by trying to use them to recreate life. Now, whether from fear of consequences or from the power itself, scientists may soon be reciting, "Now I am become life, creator of worlds," with the same kind of awe and foreboding and sense of accomplishment that Oppenheimer had when he looked at the atomic bomb. And some people will say, well, that's a good reason to stop you. But I'll leave you with this thought. Thomas Jefferson once wrote, "Liberty is the great parent of science and of virtue, and a nation will be great in both in proportion as it is free." Thank you very much.
Alta, thank you very much. That was very uplifting. It's nice to end on a positive note. Again, we're going to take questions from mics 1 and 2. We've got a couple that are submitted via Twitter. If you don't mind, we'll just start with the first one via Twitter. So the question is, so is this an issue across all areas of research or just the life sciences?
I think it's primarily across the life sciences because that's where we're seeing something that really hits that nexus between creation and some of our notions about the origins of life, which are very much tied to culture and religion. But I do think that artificial intelligence has the possibility of also moving us in that direction when we ask whether or not at a certain point the inability to distinguish between the artificial intelligence and the human will suggest that the artificial intelligence somehow has either sentience or needs to be treated as if it has sentience. And for those of you that are going to the Star Trek breakout, we will be talking about that a little bit later.
Very good. All right, microphone number 2.
Yes, thank you, and good morning. Thank you for the stimulating discussion. Matt Klunder, Harris Corporation, recently acquired ITT Excelis. And my question is a slightly different track, but I hope you'll appreciate the things I worry about as a scientist and a technologist. Human beings, the most impressive species on this planet, by far, I think, probably the most fragile species on this planet. And I say that because many things motivate us in sometimes good ways and sometimes bad ways. Example, 10 years ago, who would have thought something like this would allow someone to detonate explosive devices to blow up our sailors, Marines, soldiers? I wouldn't have thought that, frankly, but someone did. Someone unethical, someone dangerous. Mm-hmm. And why I'm bringing this up is, my opinion, I'd love your thoughts, whatever we develop, there will always be someone on this planet that will try to take it and move it in a different direction for potentially unethical reasons. But on the other hand, if Frank Kendall or Steve Welby or Arthi come and say, boy, I need something like in a year to protect our nation, security, protect our sailors, soldiers, pick one, I want to at least be able to say, gosh, we've already been working on that, but or the other comment could be, sorry, Frank, it's going to take us 3 years. Right. Does he have 3 years? No. So the conundrum I approach you with is your thoughts. I'd like us to be able, as technologists, continue on this path, and at the same time, continue on this path for ethical, legal, policy implications, and have very stimulating discussions. Is there a way that you can see us doing both of those? And I'd love your thoughts. Thank you.
So can I solve all the problems of the world within the
Of course.
7 minutes that we have left?
That's why
Absolutely.
we're here. That is why we're here.
Let me respond to you by giving you a very concrete example of exactly that problem that's being debated today for just those reasons. It's so-called gain-of-function research. It's not really the best name, but basically it's about research that takes known pathogens and makes them more dangerous by making them more transmissible and more severe in their effects and makes them more resistant to countermeasures, right? So there's been a very lively debate about whether or not this potential destructive use of biotechnology needs to be somehow banned completely and that this experimentation shouldn't go on because it will absolutely be tempting to be used for a weapon. And yet the response from some portions of the scientific community has been that unless we actually do this, we won't know how to counter it, we won't know how to anticipate it, we won't know how to detect it, so we absolutely need to do the research even if it's purely for defensive purposes, right? So we've seen exactly this example and exactly this debate. Where is that debate going? It's going to look at various kinds of regulatory systems to see if there's ways to monitor in a fashion that reduces the chance of somebody getting the materials necessary or getting the expertise necessary to turn this to a destructive use while protecting the laboratories that are doing it for benign or useful purposes. But it's unlikely it'll be perfect. We also have seen in the area of stem cell research how a number of fraudulent clinics have sprung up all over the world, and regrettably here in the United States as well, offering pseudo-cures because of the kind of magic of the word stem cell, or to go back to one of the DARPA risers, the magic of the word nanotechnology, because they've now got nano stem cell clinics. I love that. And we've been struggling globally to figure out how to restrain those laboratories under the varying regulatory systems that we have for licensing facilities, personnel, et cetera. But the answer usually lies in that kind of regulatory approach, which is a combination of oversight, materials control, auditing, and result evaluation. Again, not perfect, but since very few things are perfect, the question is, can you get enough benefit to outweigh the residual risk?
Thanks, and I offer we can build safeguards, in my opinion.
Okay.
Thank you. Thank you very much.
Very good. Stay with question, or mic number 2.
David Mascarenhas from Los Alamos National Labs. So roughly speaking, I think of physics as kind of studying truth of the material world and engineering applying those principles. And I kind of think of law as saying whatever I can successfully convince other people of becomes the truth, something along those lines. But when I read, I read a lot of ethics and science kind of, publications. It's not clear to me how ethicists see their role kind of in that context. Could you talk about that?
There's a lot of people that wonder about that. And frankly, if I'd had my druthers, I would have introduced myself as a professor of law rather than as an ethicist, because I completely get your point. Ethics is not, in my opinion, a field in which you're trying to tell people what is right and wrong, right? Moralists will do that for you. What we try to do in ethics is to clarify what the bases are for our analyses. So for example, you might be somebody who thinks about things solely in terms of their consequences, and you want to measure what's the benefit, what's the burden, and decide after that, if there's more benefit than burden, it's a good thing. Whereas your analysis might be based upon a list of absolutes. You do not do certain things because they're simply wrong, even if they have a benefit. Those are two very different kinds of approaches to analyzing a problem. And the role of an ethicist is to help people recognize that in their own thinking, critique their own thinking, ask is that how I want to approach things. If I'm using a long list of absolutes, where did I get that list from? Is it changeable? If I'm using this kind of utilitarian balancing process, how do I really know, first of all, what the consequences really will be? And second, how do I evaluate one as good or bad without reference to his list of things that are absolutely good and bad? So it's more about a way to think about things so that people can at least debate them more sensibly with more nuance and hopefully understand where each other's instincts are coming from so that we can address each other more directly.
Thank you.
Very good.
And by the way, we don't think that law discovers truth. We simply discover a moment at which we don't know any better, so we might as well decide. It's
Also, we have one over microphone number 1.
So, Dr. Ami Magnus again. I'm concerned about how we decide. And one of the reasons is overspecialization, is that human beings tend to do what they do well past the point of obsolescence. We tend to overspecialize. We use grading systems that in our school systems overemphasize cognitive comprehension. That's how we judge intelligence. So we don't necessarily judge things by a full portfolio. We reduce too soon, as we would say in information fusion. So the thing that I'm concerned about is, are we good at preventing overspecialization? And that's why I say we need to put the brakes on these sort of things. And is there a benefit, can we get a benefit from increasing diversity, and how would we understand that benefit? Thank you very much.
Well, I think it's been a challenge for anybody here who's familiar with universities to figure out how to both ensure that people get deep training through their discipline, but also have this kind of interdisciplinary experience across departments. But we do that even when we don't have people who are interdisciplinarily trained, by collecting people who have different disciplines and forcing them to talk to each other. For example, the CRISPR-Cas9 germline editing question. The National Academy of Sciences and the National Academy of Medicine, formerly the Institute of Medicine, have jointly embarked on an endeavor in which there's going to be a scientific meeting in October, an international summit in December, and the beginning of a study committee in January, all of which are going to be populated by people who come from across disciplines, not just the clinical sciences or the basic research sciences, but also sociology, law, philosophy, religious studies, and to look at exactly how we should think about this technology, its implications, and its potential acceptance in the public, not only here, but across very different cultures and very different histories about genetics. And the hope is that by gathering all those people in the same room and forcing them to talk to each other, you will get the benefit of the interdisciplinarity regardless of their training. I think, if I understood correctly from Arthi, that's exactly what she's hoping to accomplish here with the mix of people that she's gathered here for this particular meeting. He asks, yes, but will they understand each other? I've served on a lot of these, and I suspect many of you have as well, and the answer is, for the first 2 meetings, absolutely not. But by the 3rd meeting, remarkably, the answer is, yeah, kind of, and by the final report, really pretty well. I think everybody who participates in these group endeavors comes away thinking that they probably got more out of it than they gave in, because they now have this gloss of all the other fields. I guarantee you I couldn't have rolled off things like gain-of-function research if I hadn't served on that committee.
Very good. Alta, thank you very much. It's been an honor to have you here today.
Thank you.